All right, here's a key for the Chapter 8 quiz. Number one, for a fixed voltage, the current I, so I is the current, flowing in a wire varies inversely as the resistance R. And there's a fixed voltage, which would be your K. So in that case, if it varies inversely as R, I is your current, and that's going to vary inversely as your resistance R, so that's going to be K divided by R. If the current is 8 amps when the resistance is 15 ohms, so the current is I, so that is, if the current right here is 8 amps, that means that your current is, remember your I, so my I is going to be 8. So if I put 8 in for I, that's going to be equal to K divided by 15 ohms, a resistance of 15. So that will allow me to solve for the fixed voltage K. So if I solve that for K, and here you have a proportion, you can use the cross products. And so the cross products, K times 1, is going to equal 8 times 15, which is 80 and 40, which makes 120. So the voltage is 120, which allows you to write your formula essentially as the current I is 120, the fixed voltage, divided by the resistance. And then the question finally asks, what is the resistance when the current is 5 amps? So if the current is 5 amps, then what is the resistance? That's your missing variable R. And so again, what 120 divided by what number is 5, or you could use your cross products and set up an equation. 5 times R, those cross products are equal to 120 times 1, which means we have a resistance of, dividing both sides by 5, 24 ohms. All right, so there's question number 1. Question number 2, we're asked to multiply this rational expression, and before we multiply, we should factor and see if anything reduces. So let's see what we're working with and factor this as much as possible. And some common factors will probably cancel out. So here we have the difference of squares. This is 3x plus 1 times 3x minus 1. Okay, so that changes. Here's the difference of squares again, and this is x plus 3, x minus 3. 3x plus 1 I can't do anything with, nor can I do anything with x plus 3. So if I clean this up and rewrite it nice and neat, I have up in the numerator a factor of 3x plus 1, 3x minus 1, and x plus 3. Because when I multiply fractions, remember when I multiply fractions, I multiply everything in the numerator, which means that stuff, times everything in the denominator, which is that stuff. So my denominator, nice and cleaned up, is going to be x plus 3 times x minus 3 times a factor of 3x plus 1. And so what you'll see here is that there's some common factors in the numerator and denominator. There's a common factor, 3x plus 1. So if I factor 3x plus 1 over 3x plus 1, that's just equal to 1. So therefore it's not going to really do anything, so I can get rid of it. Same thing with the x plus 3. So the only factors I have left are here and here, which ends up being the final product in simplest form for this one here. And then the values that the denominator cannot be 0, so we have restrictions on our x values. Our domain is restricted from values negative 3 coming from here, positive 3 coming from there, and negative 1/3 coming from there. Question 2, is a very similar question, except for we're dividing. So you have to remember that dividing is the same as multiplying by the reciprocal of that. So I'm going to factor and reciprocate this second expression. So if I factor the numerator, I get x times x plus 7. That comes from here, of course, because I flipped it. And then here, that's the difference of squares, x plus 7 times x minus 7. So I change the division to a multiplication by multiplying by the reciprocal. And then I'm just going to clean everything up and write out all my factors. So my numerator, if I follow this now, my numerator is going to have 3x minus 21 and x times x plus 7. And then my denominator is going to have 3x and x plus 7, x minus 7. So I'm going to clean that up and rewrite those all together. So I have here, well, and actually this factors out of 3, so that's 3 times x minus 7. So I'll have 3 times x times x plus 7 times x minus 7. And so there's all my factors there. See, there's the 3, there's the x plus 7, and there's the x minus 7. And then in my denominator, I have 3x. So I have a 3 and an x coming from right there. And then I have a x plus 7 and an x minus 7. So funny thing here is that I actually have the same exact stuff in the numerator and denominator all together. So that and that are 1, that and that make a factor of 1, that and that make a factor of 1, and same thing there. So really, all of this right here is equal to just 1. That whole expression is the same as just 1. So instead of number 1 on the hockey goalie's jersey next year, we're going to put this rational expression and see if people figure that out. Some restrictions in the domain are that x cannot equal 0 or plus or minus 7, because that would make the denominator 0, and you can't divide by 0. In number 4 here, I'm adding two rational expressions. So this is like adding fractions. You have to get a common denominator. And in order to find a common denominator, it's helpful to factor our denominators so that we know exactly what we're working with here. And so if I factor this difference of squares again, we have a factor of x plus 2 over x minus 2. And over here, of course, we just have a factor of x minus 2. So if we want those to be the same, then we need to add a factor of x plus 2 to the expression here on the right. So in order to do that, I multiply by x plus 2 over x plus 2, which is really just a fancy looking 1, and I will then have common denominators. So if I do that, my first expression doesn't change at all, but my second expression becomes, now if I multiply the 1 times the x plus 2, I get just 1x plus 2 over, and then I have my common denominator, x plus 2 times x minus 2. So when I add those together now, I add the numerators, which means I add x and I add x plus 2. So when I add x plus 2, this is where some of you went wrong. I get 2x plus 2 over, now for whatever reason, some of you just left off the denominator totally. You just didn't even write anything on there. But when you add fractions, you keep the denominators the same. Once you get your common denominator, that stays. So I have here, just a minute. Something's going wrong with my computer. I have to pause it here just a second. Okay, so sorry about that. So we have, you can't just leave off your denominator. Of course, when you add fractions, you keep the same denominator. Kind of like I was talking to some of you. If I add 1/2 plus 1/2, that's 2 halves, right? That's not just 2. Some of you are just adding the numerators and forgetting about the denominator. But if you add a half plus a half, that's equivalent to 2 halves, which is the same as, of course, just 1. So you can't just leave off the denominator. Now in this case, I can factor the denominator a little bit, and I'm going to go ahead and factor that. So my final answer could be 2 times x plus 1 all over x plus 2 times x minus 2, and you factor that just to see if there's anything else that may reduce, and nothing actually reduces, so you can leave your answer like this, or you could multiply out the denominator, so you had x squared minus 4, that's fine as well, but nothing else cancels here, and restrictions on the domain are equal to x cannot be plus or minus 2. So there's number 4. Number 5, very similar question, except for we are subtracting instead of adding. And this one's kind of nice because you're given common denominators. So if you're given common denominators, all I have to do is take the numerator and subtract the other numerator from it. So if I want to subtract 2x minus 1, or 2x subtract 1, I can't do that until I know the value of x, so I just leave that as an expression 2x minus 1, and that's over 4x minus 2. And some of you had this as your answer, and that is almost correct. It just reduces if you factor the denominator. And some of you, again, just totally left off the 4x minus 2 part, which you can't just leave the denominators off. That's not accurate. So that is the same as this, and if I factor the denominator, I end up with 2x minus 1 over factor a 2 out, and I'm left with 2x minus 1. And so you'll see that the denominator has a common factor of 2x minus 1 in the numerator. So what I really have left when I'm all said and done here is 1 over 2. So that whole expression is the same as 1/2 so long as x is not equal to positive 1/2 in the denominator. I think this confused some people because some of you thought you were solving an equation here, but if you looked at the original problem, do you see any equal signs there at all? And the answer is no. So we're not solving an equation. We're not looking for a value for x. However, it's a little funny because this simplified to be just a value. So I think some of you got confused and thought you were solving an equation there. But this whole expression is equivalent to 1/2. So I'm going to wrap up the first part to this key since we have the 15-minute maximum. So then look for part 2, and we'll pick up on question 6 in part 2.